I'm on page 151 now. Completing the square is an extension of the square root method for solving quadratic equations, but it's a little bit tricky because you have to be able to recognize a perfect square trinomial and figure out how to fit it into your equation. But if you can use this method, it's often the quickest way to solve these. These first two are perfect squares. X squared plus 4x plus 4 equals x plus 2 squared. And x squared minus 6x plus 9 is x minus 3 squared. X squared minus 25 is not a perfect square. It's a difference of squares. It factors into x plus 5 times x minus 5. If this middle number, the b, is even, you can get a perfect square by making the last term b divided by 2 squared. Here b is -4. -4 divided by 2 is -2. Square that, it's 4. Eight divided by 2 squared is 16. -10 divided by 2 squared is 25. And this is 1. To complete the square, we add numbers to both sides to get a perfect square, then factor and use the square root method to solve. For a, the middle term is -10. To get a perfect square, we need the last term to be +25. If we add 31 to both sides, we have x squared minus 10x plus 25 equals 31. X minus 5 squared equals 31. X can be 5 plus or minus the square root of 31. You can try B yourself. For C, I want a +1 at the end. Add 1 to both sides. Take the square root of both sides. The square root of -9 is 3i. And that gives us x equals -1 plus or minus 3i. This last one is a little trickier because the first term is multiplied by 4. If I break it into 2x plus or minus something times 2x plus or minus something, I can see I'll get 4x squared. And then I don't want the sum of the outer and inner to be more than 4. Let's try +1. It looks like I can complete the square by turning this -1 positive. So I'll add 2 to both sides, and that gives me 4x squared plus 4x plus 1 equals 2. Take the square root of both sides. X equals -1 plus or minus the square root of 2 over 2.